So here's a max-min word problem. How do I know it's a max-min word problem? Well, let's read it. 3 meter length wire cut into two pieces. First piece is to be made into a square. Second piece into a rectangle where the base is twice the height. Okay. How do I cut the wire to make the sum of the two areas a maximum? I had to wait till the last word. So I'm trying to maximize what? I'm trying to maximize, so now I know it's a max-min word problem. I'm trying to maximize the sum of the area of the square plus the area of the rectangle. All right, so let's see what we got here. There's the square. If it's a square, it's going to be x and x. So the area of that would be x squared. Here's the rectangle. And the rectangle has to be twice, the base has to be twice that. So this has to be 2x and this has to be x. So its area would be 2x squared. Oh, wait a minute. I don't know ahead of time if this length of the side of the rectangle is the same as this length as the side of the rectangle. So I think I'm going to call that y, because I don't know if they're supposed to be the same. So now let's write out the function that I'm trying to maximize or minimize. The area is equal to, okay, area of the square plus area of the rectangle. So that's what I'm trying to maximize. Now, what stops me from making like a massive square and a massive rectangle? Well, I only have 3 meters of wire. So all the way along here, x, 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 this length plus this length, 2y plus y plus 2y plus y, that total perimeter of both those shapes has to be 3 meters. So 4x for the square and 2, 3, 4, 5, 6, 6y for the rectangle, that has to equal 3. That's my constraint. I wanted a constraint because I want to maximize this area function. So I want to take the derivative, set it equal to 0. I'm looking for a place where the slope is flat. I'm looking for a maximum. So I want to differentiate, but I want to differentiate with respect to one variable. My area function has two variables in it, x and y. So I'm going to get rid of one of the variables. Let's solve this equation for y. So 6y is equal to 3 minus 4x. Divide everything by 6. That's 1/2 minus 2/3 x. So y is equal to 1/2 minus 2/3 x. So now I can write my area formula just in terms of, so everywhere there's a y, I'm going to put a 1/2 minus 2/3 x. So now my area formula is strictly in terms of x. Now the next step is mechanical. I'm going to be taking the derivative, setting it equal to 0, solving for x. So when I want to take the derivative, I want an a prime here. I could differentiate it as it stands. In fact, let's do that. I'm just going to straight differentiate. But I was thinking maybe I should like multiply this bracket out or something and then differentiate it. I think it's safer for me to differentiate using the chain rule. Less chance of an error. So a prime is equal to, okay, 2x. I'm differentiating with respect to x. The 2 is a constant. This 2 is a constant. So I'm differentiating this bracket squared. That 2 comes down, chain rule. Leave the middle alone. Subtract 1 from the exponent, so that's a 1. I'm not going to write it, but it's to the power of 1. And then multiply by the derivative of what's inside. The derivative of what's inside is minus 2/3. So that way I didn't have to square out the bracket. Now I'm setting that equal to 0. The a prime is the slope. I'm looking for where the slope is flat, because that would be a maximum part. So I set a prime, the slope. I set the slope equal to 0. Now it's a matter of solve for x. All right, there's some algebra here. I'm going to bring this whole piece, has a minus 2/3 on it. I'm going to bring it to the other side so it becomes a plus 2/3. Is that what I'm going to do? Yeah, let's do that. No, let's clean this up. So, I mean, it's just solve for x. I'm going to multiply this minus 2/3 times this 4 first. So that's minus 8/3, 8/3, 1/2 minus 2/3 x equals 0. Um, I don't like this fraction. I could multiply this fraction through this bracket. There's a couple of things that'll mess me up there potentially. Multiplying with a minus through, I got to remember to change all the signs. I'm just going to take this whole thing and just to get rid of the fraction, at least at 8/3, I'm going to multiply the whole thing through by 3. That's going to be 6x minus 8, and 0 times 3 is 0. So at least that gets rid of the fraction. Now I feel a little bit safer multiplying this 8 through. 6x minus 4, minus a minus is a plus. 8, that's going to be 16 over 3x is equal to 0. Okay, this 6x, I could do the same trick where I multiply everything through by 3 again, I guess. But let's just write this 6 as 18 over 3. So now I can write 18 over 3x plus 16 over 3x. That's going to be 18 plus 16 is going to be 34 over 3x is equal to 4 when I move that minus 4 over. So now x is equal to, multiply the 3 up, 12. 12 divided by 34, which I guess is 6 divided by 17. Okay. I can't just stop and go, hey, x is equal to, I need to answer the question. The question specifically is, how do I cut the wire? So I need one square piece, which is 4 x's. So I need to tell, like, cut the wire into a 4 x's. So cut the wire into a 24 by 17 meter piece, and then that's for the square. And I guess I could say use the rest to make the rectangle. I could also figure out how much the rest is by, if I know that x is equal to 6/17, I could plug into here and get what the y is. I'm going to be lazy and I'm just going to write use the rest for the rectangle. And that's answering the question, kind of. That rest piece, that's 9 over 34. So 24 over 17, which I guess would be 48 over 34. So a 48 over 34 and a 9 over 34 you'd cut it into those meter pieces. And anyway, I just didn't want to end the video on the lazy thing.